Now let's answer question C2A, which is, describe how a dry and a fairly pure sample of silver chloride can be prepared in the laboratory. Here's how a dry and fairly pure sample of silver chloride can be prepared from sodium chloride and silver nitrate in the laboratory. 1. Mix aqueous sodium chloride with aqueous silver nitrate in a test tube and shake the content. 2. A white precipitate of silver chloride forms. 3. Filter the mixture to collect the precipitate. 4. Wash the precipitate with distilled water to remove impurities. 5. Dry the silver chloride between filter papers or in a warm oven. We come to C2B. Write the net ionic equation for the reaction in A. Include state symbol. To write the net ionic equation, we'll follow these steps. First, we should understand that the reaction is a double displacement or precipitation reaction, and this is the equation, which is AgNO3 plus NaCl, which is equal to AgCl plus NaNO3. Now, when writing in ionic form, spectator ions, which are sodium raised to the positive and nitrate raised to the negative power of 3, are removed. So let me cancel them out. Therefore, the net ionic equation is Ag positive, aqueous, plus Cl negative, aqueous, which will produce Ag, Cl solid. This shows the formation of silver chloride from silver and chloride ions. Next is C2C. Use the equation in B to calculate the mass of silver chloride expected if 1.7 grams of silver nitrate reacts with excess sodium chloride. To calculate the mass of silver chloride formed if 1.7 grams of silver nitrate reacts with excess sodium chloride, I will take the following steps. Step 1. Find molar mass of silver nitrate is equal to 108 plus 14 plus 3 times 16, which is equal 170 grams. Step 2, find molar mass of silver chloride is equal to 108 plus 35.5, which is equal 143.5 grams. Step 3, equate 170 grams is equal to 143.5 grams and 17 grams is equal to X. Now we do cross multiplication as follows. Then we come up with these expressions. 170 grams times X is equal to 1.7 grams times 130.435 grams. Next, we evaluate 170 grams times X, which will give us 170 X grams. Thereafter, we evaluate 1.7 grams times 143.5 grams, giving us the product of 243.95 grams. Now we divide 243.95 grams by 170 grams, giving us 1.435 grams. Rounding it to the nearest one decimal place will give us 1.4 grams, which is the mass of silver chloride. So, the theoretical mass of silver chloride formed is 1.4 grams. We come to C2D. D. Calculate the percentage yield if 0.95 grams of silver chloride was obtained. To calculate the percentage yield if 0.95 grams of silver chloride was obtained, we will follow the following steps. 1. Write the formula, which is percentage yield is equal to actual divided by theoretical times 100. Percentage yield is 0.95 divided by 1.24 times 100, which will give us 0.662. Then we multiply 0.662 by 100%, will give us 66.20%. Rounded to a whole number, the percentage yield is 66%. I hope this walkthrough helped you understand the topic. If you found this video helpful, please subscribe to our channel and hit the notification bell so you never miss an update. Keep practicing, keep learning.